Hello, my dear students. This is Raman Rana here, your mathematics teacher, Cambridge International School, Dasua. Today, we will again revise chapter circle. Today, we will discuss the all examples and a few questions.
In circle chapter, we have 3 examples, and all the 3 examples are very important. So example number 1, prove that in 2 concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So concentric circle means the circle who have the same center. If we have O as the center and one circle we have and another circle these 2 circles are concentric when their center coincide. Center is same, center is O. Now we want to prove that the chord of the largest circle which touches the smaller circle, chord of the larger circle let A B is the chord on this chord of the larger circle and touches at point P here. So P is the point of contact. So we want to prove here that this point of contact divides the chord into equal parts. So here we join point P with the center O, and here to prove we have to prove that AP is equal to BP, means point P or point of contact divides the chord into equal parts. So here we know that here this AB is also tangent on the inner circle. So this angle is always 90 degree. So here if we join OA and OB, if we join OB and OA, so we have 2 triangles, triangle AOP and BOP, in which in triangle AOP and triangle BOP, we have AO is equal to BO, radius of the circle, and we have angle P is equal to angle P, both 90 degree. So first theorem says that the tangent make 90 degree with the radius at the point of contact, and the side OP is equal to OP is common in both. So we have in these 2 triangles, this triangle AOP is congruent to triangle BOP by right angle, hypotenuse and side. Right angle, this angle is right angle, hypotenuse, this radius is the hypotenuse here, and OP is the side. So by right angle, hypotenuse, side, rule of congruence, these 2 triangles are congruent, and by CPCT, corresponding parts of the congruent triangle says that AP is equal to BP. AP is equal to BP. So this is about example number 1. It is same like we have proved theorem to the length of tangents. There also we are using the property RHS, right angle, hypotenuse and side. So these all examples are very important. Example number 2. Most of the students are misunderstood with the example number 2. It is a simple one, and I will discuss this example in another way also, one more way. Let's first discuss these questions as per the book. Here TP and TQ are the two tangents from point T, and from point P draw a radius OP. We have to prove that angle PTQ is twice the angle OPQ. So let's suppose this angle here is theta, angle PTQ. This angle is theta. Now in triangle TPQ, first triangle TPQ, this length of the tangents are always equal. So this is an isosceles triangle, means both angles, angle TPQ and TQP are equal. So angle TPQ is equal to angle TQP is always equal to, the sum of these three angles is 180 degree. So it is always equal to half of 180 minus theta. So I am again repeating, the sum of all these three angles, this angle plus this angle, these two angles are equal. So here, like if angle A plus theta is equal to 180 degree. So A plus A is 2A. So this twice of A is equal to 180 minus theta. So A here is equal to half of, so 1 by 2 into 180 minus theta. So I hope this step is very much clear. Now we know that the angle here TPO is always 90 degree. So here this angle TPQ plus angle OPQ is 90 degree. Also angle TPQ, this TPQ plus angle OPQ is equal to 90 degree, because we know that tangent make a 90 degree with the at a point of contact with the radius. So here we will substitute the value that half of 180 minus theta plus angle OPQ is equal to 90 degree. Even here we can write down this is equal to 90 minus theta by 2 here. So 90 minus theta by 2, 90 degree minus theta by 2. So plus angle OPQ is equal to 90. So 90 get cancelled with 90. So we have angle OPQ is equal to theta by 2. Or theta is here angle PTQ. This angle is theta. So this implies that the angle theta is equal to twice of angle OPQ. So this is the way which is given in the book. Now one more easy way, if here I am joining this OQ, now I have a quadrilateral TPOQ. Another way to solve this question, we know that here Q is also a point of contact, so this angle is also angle Q and angle R are of 90 degree each, right angles. Now in a quadrilateral TPOQ, we know sum of all these four angles is always 360 degree. So this implies that here, because TPOQ is a quadrilateral, so here angle theta, that PTQ, that is angle theta plus angle POQ is equal to 180, because I have subtracted two right angles. So from this quadrilateral angle, this theta plus angle POQ is always 180 degree. So this angle POQ is always equal to 180 minus theta. Now here in this triangle POQ, if I am drawing a triangle POQ here, POQ, this angle is 180 minus theta. These two sides here, these two sides are the radius. These sides are the radius. So this is also isosceles triangle. So let the angles are X and X. Both angles are equal. Same in this triangle also. So according to angle sum property of a triangle, we have X. This angle is X. This angle is also X here. So therefore X plus 180 minus theta is equal to 180 degree. So we have to 180 get cancelled. Twice of X is equal to theta will become positive, and the X is equal to, this is proved already. This is that PTQ is, this angle is PTQ and X here is OPQ. So I hope you all are, this is also a very easy way. So angle PTQ is twice of angle OPQ. Let me recapitulate here. Thus another way, TPOQ is a quadrilateral. Sum of all four angles is 360. So subtracting one right angle from here and one right angle from here, so we have left with angle this theta, and angle POQ is 180 degree. So now in this triangle, this angle is 180 minus theta. So X plus 180 minus theta is equal to 180 degree. So 180 and 180 get cancelled. Twice of X plus X is twice of X is equal to theta. This minus theta becomes plus right hand side. So we have here X is equal to, X is angle POPQ. So we have this statement that angle PTQ is twice of angle OPQ. So I hope now this question is very much clear to you people. Example 3. In example 3, a circle of radius 5 cm and a chord PQ of length 8 cm, and from point T we have two pair of tangents TP and TQ. So here in this example 3, we have to find, here radius of the circle is 5 cm. To find that we have to find the length of TP here. Length of the tangent. TP and TQ are equal, so we have to find the length of the tangent. So here we know this angle is always 90 degree. Angle TPO is 90 degree. One more thing, we will apply the previous knowledge of circle in grade 9, that chord PQ here, this if we join T with O, this angle is also 90 degree, and this PR is equal to RQ. So we have two triangles. One is triangle TPO, it is TPO, and another is triangle PRO and triangle PRO. So here in both these triangles, angle P and angle R of 90 degree each. So I will prove these two triangles similar, because in these two triangles one angle is 90 degree and angle O is common in triangle PRO and TPO. This angle is common in both the triangles. So by AA rule of similarity, both triangles are similar, and by applying the basic proportionality theorem, we can very easily find the length of the tangent here. So here we will write here that angle P here is equal to angle P is equal to angle R, both 90 degree. Also the length of PR is equal to half of 8 cm, that is 4 cm. Here PO is equal to 5 cm. Now by Pythagoras theorem, we have to find RO. The hypotenuse square, that is 5 square, is equal to PR square, that is 4 square, plus RO square. So this implies that RO square is equal to 25 minus 16, which is equal to 9. So RO is equal to under root 9, which is equal to 3. So here this RO, this side is now 3 centimeter. 4, 5 and 3 centimeter. Now these two triangle TPO and PRO, these two angles are 90 degree. Angle O is common, that is POR is equal to angle POT, same angle. So therefore triangle TPO is similar to triangle this is similar to triangle your O with O, R with P, and here is point PRO by AA rule of similarity. Double A rule, angle. This angle P is 90 degree, here R is 90 degree. So angle O is common in both. So if triangles two triangles are similar, then the ratio of their corresponding side is always same. So here we can write down by basic proportionality theorem, the ratio of the corresponding sides. So here we want to find TP. So we can write that TP upon PR is always equal to, that is PO upon RO. This side is RO. Second side here I am taking PO upon RO. Although it is also equal to the third side, that third side is TO. So but we are only interested with this TP and we have rest these sides here. So we can write down TP upon PR. PR is 4 is equal to, here PO is 5 and RO is 3 centimeter. So this implies that the TP is equal to 5 upon 3 into 4, that is 20 by 3. So the length of the pair of tangents is equal to 20 by 3 centimeter. So my dear students, I hope you are very much clear with this question. Here we are applying the similarity criteria of the triangles, and by applying the basic proportionality theorem, the ratio of, if two triangles are similar, then the ratio of their corresponding side is equal. So here TP upon 4 is equal to 5 upon 3. So TP is 20 by 3. Question number 8, exercise 10.2. In this question, a circle is circumscribed by a quadrilateral A, B, C, D. So in this situation, always the sum of the opposite sides of a quadrilateral is always equal. So in this case, we want to prove here that AB plus DC is equal to AD plus BC. So this is always true for any quadrilateral. We have one more question in which we have to prove that it is a rhombus is a parallelogram. So here let's prove first this question. We know that AP and AS are the two pair of tangents. So we can write down here that AP is equal to AS. This is the equation number 1. Similarly, BP is equal to BQ. These are also the pair of tangents, and we know the length of pair of tangents are always equal. Similarly, we have CQ is equal to CR, and the fourth side, that is DR and DS, are also equal. DR is equal to DS. So this is second, third and fourth. Now to prove these, this is left hand side and right hand side. We will take one on left hand side. Let's take AP left hand side, and one we'll take as right hand side. And here AP is equal to your AS. Now BP or PB is equal to, right hand side I am going for BQ, PB and BQ. Now the third side, that is QC and CR. Here QC, that is left hand side I am going with RC or CR, and this side I am going with CQ or QC, and third is left with DR left hand side, and DS plus DS on right hand side. So here AP plus is equal to AB, and CR, here CR plus RD or DR is equal to CD, and here AS plus SD, this is AD, and here we have BQ plus QC is equal to BC. So always whenever a circle is circumscribed by a quadrilateral, then the sum of the opposite pairs of the quadrilateral is always equal. Means always AB plus DC is equal to BC plus AD. Always. So next, question number 9. We have one circle and with the center O, and PQ is a diameter. PQ is a diameter of a circle. O is the center. We have two pair of tangents passing through point P and Q. This is one tangent, this is X, Y, and another tangent this point is Y dash, and this point is X dash. Question number 9 here. Now we have a point A here and point B here. Such that this is point B. This line AB, line segment AB, touches the circle at point C. So here we want to prove, diagram is given in the book, we want to prove that this OA join O with A and O with B here. To prove in this question, we want to prove that angle AOB is a right angle, 90 degrees. So here we want to prove angle AOB is 90 degree. So here we will join O with C, and we know that here this angle is 90 degree because C is now a point of contact. P is already a point of contact. So in these two triangles, we have angle, this is angle 1 and this is angle 2. From these two triangles, we can say angle 1 is equal to angle 2. Because these two triangles APO and ACO, they are congruent triangles, and by CPCT angle 1 is equal to angle 2. So similarly, it is by CPCT here, and similarly here this angle is also 90 degree and this angle is also 90 degree. OB is the common hypotenuse, and like here this is the radius, radius here, this is also the radius. So in these two triangles, triangle OQB and OCB, by CPCT we have angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Same logic. Here Q is also 90 degree and C angle is 90 degree. So PQ is the diameter. Therefore angle 1 plus angle 2 plus angle 3 plus angle 4 is always equal to 180 degrees. Straight angle. This angle is a straight angle 180 degree. So we can write on here that twice of angle 2 plus twice of angle 3 is equal to 180 degree. Take 2 common. Angle 2 plus angle 3 is equal to 180 degree. So here we have angle 2 plus angle 3 is equal to 90 degree. So this implies that angle AOB is equal to 90 degree. So I hope you are very much clear with this question. So dear students, this is a very simple chapter and we have revised all important questions. So I hope you understood the concept of the pair of tangents. Thank you very much.